Good morning, 10th standard. Now we have to do the last exercise from chapter number 4, exercise 4.4 on page number 91. The first question of this exercise is based on a concept which I have already discussed with you. Let's take a look at first question. Find the nature of the roots of the following quadratic equations. If the real roots exist, find them. Now this question is based on the type of discriminant that we obtain. So what we're going to do is we are going to use the quadratic formula, obtain the discriminant. Based on the discriminant, we will be able to tell what kind of roots the equation will have. And if there are real roots, which is in two cases, either the discriminant should be greater than 0, in which case the equation has two distinct real roots, or discriminant should be equal to 0. In this case, two equal roots are obtained. So if the discriminant is less than 0, there are no real roots. So this is what we will do. We will find out the discriminant, and if the discriminant is greater than 0 or equal to 0, we are going to find the answer. If the discriminant is less than 0, we will not find the answer. Question number 1, first part. The equation given to us is 2x square minus 3x plus 5 equals to 0. So the first thing we do to find out the discriminant is to compare it with the standard form. So comparing this equation with the standard form, I can find out what A, B, C are, the coefficients of x square, x and the constant term. This is 2, then B is minus 3, constant is plus 5. Using these three coefficients, the next step is to find out the discriminant given by B square minus 4AC. Let's use the values. So this is 9 minus 40. This is minus 31. The discriminant is less than 0, so no real roots. So we will not calculate the answer. Second part is 3x square minus 4 under root 3x plus 4 equals to 0. Comparing it with the standard form, ax square plus bx plus c equals to 0. A is 3, b is minus 4 root 3, c is 4. Now we find the discriminant using the values. This will be 48 minus 48 equals to 0. So discriminant is equal to 0. So therefore the equation has two equal real roots. And now we are going to find out the values for the same. The values of the root, that means the value of the variable, will be given by minus b plus minus square root of d by 2a. If you remember in my earlier videos where I discussed the nature of roots, I explained that when d is equal to 0, the two equal roots are minus b over 2a, because discriminant is 0. So square root of 0 will be 0, you will be adding 0, you will be subtracting 0. So the two values will be minus b over 2a minus b over 2a. If you want, you can use this directly to obtain the answer. Remember, you have to express it twice. You have to write the same answer twice, because there will be two equal real roots. So I'm going to use this as such, the formula that we apply to find out the roots. Minus 4 root 3 plus minus square root of 0 in the denominator, 2 multiplied by 3. So this will be 4 under root 3 plus minus 0 over 6. So taking it once with the addition and once with subtraction, 4 root 3 plus 0 by 6, 4 root 3 minus 0 by 6. So this will give you two answers. This is 4 root 3 by 6 This is 2 root 3 by 3, and same way this becomes 4 root 3 by 6, which again simplified is 2 root 3 by 3. So these are the two equal roots of equation number 2. This is the third equation, 2x square minus 6x plus 3. Start by equating or comparing it with the standard form of a quadratic equation. Identify ABC. From here, A is 2, B is minus 6, and C is plus 3. Next step, find the discriminant, B square minus 4AC. So this is 36 minus 24, which is 12. So discriminant is greater than 0. This means the equation has two distinct real roots, two different real roots. We will be getting two different answers. So obtaining the roots means the value of the variable. The variable here is x. So value of x will be given by minus b plus minus square root of d. In the denominator it would be 2a. Substituting the values, square root of 12 in the denominator, 2 into 2. So this is 6 plus minus. To solve the square root of 12, prime factorize. So 4. So this factor exists in pairs. So square root of 12 will be 2 into 2 into 3. Since this is a pair, it will be out of the root, and in the root we will be left with 3. So this will be 2 root 3. In place of root 12, this will be 2 under root 3. In the denominator it is 4. Now let's take it once with addition and once with subtraction. Six plus 2 root 3 by 4 and 6 minus 2 root 3 by 4. Don't cancel 2 and 4 because it's a binomial. You cannot cancel one term with the denominator. Take 2 common from the numerator. Now you can cancel this monomial with the monomial. So this comes out to be 3 plus square root of 3 by 2. Similarly, you can simplify the second factor. From the numerator, let's take 2 common. Now this can be cancelled with the denominator. So the second root is 3 root 3 by 2. This is the answer for equation number 3. Question number 2 of the exercise. Find the values of k for which each of the following quadratic equations have 2 equal roots. In your quadratic equations, there is a missing value, k. You have to find that value of k, and the condition to find k is the equation should have 2 equal roots. Now a quadratic equation will have 2 equal roots if its discriminant is equal to 0. So that is the condition we will use to find out the value of k in both the equations. Let us see how we are going to solve. The first step is to compare the equation with the standard form. So comparing it with ax square plus bx plus c equals to 0. A is 2, b equals to k, c is 3. The next step is the condition that we have. Equation will have 2 equal roots when discriminant is equal to 0. So discriminant is given by b square minus 4ac. So this implies b square minus 4ac should be equal to 0. Let's use the values. B is k squared, 4 into a into c equals to 0. So k square minus 24 equals to 0. K square equals to 24. From here k will be equal to square root of 24, and every time we take square root we take positive and negative. So from here k equals to, simplify the square root of 24, by taking prime factorization, pairing up the common factors, pairing up the similar factors, you get the answer as plus minus 2 under root 6. So these are the possible values of k for which the equation will have two equal real roots. Let's do the next part. This is the second equation that we have. Now this does not look like a quadratic equation, but it is a quadratic equation if you expand the brackets. Let's simplify this and obtain or put the equation in standard form. So opening the brackets, this is kx square minus 2kx plus 6 equals to 0. Now we have a term containing x square, a term with x and a constant. So this is the quadratic equation. Comparing it with the standard form, so the standard form is ax square plus bx plus c equals to 0. We get a, b, c. A is k, b is minus 2k. Remember, you have to take the coefficient of x. So x will be omitted, you take the remaining part. The constant here is 6, positive 6. Now we apply the condition for the equation to have two equal roots. For equal roots, d should be equal to 0. This means b square minus 4ac will be equal to 0. Using the values, we get minus 2k square minus 4 into k into 6 equals to 0. So this is 4k square minus 24k equals to 0. Factorize. Now this itself is a quadratic in k. You're going to get two values. So 4k is common, k minus 6 equals to 0. From here 4k equals to 0 or k minus 6 equals to 0. Just like a quadratic equation, we have two linear factors. Each of these linear factors will be taken equal to 0 and then we obtain the value of k. So from here k equals to 0 and from here k equals to 6. And just like in a quadratic equation, we will see which of these is a correct value. Maybe both are correct, maybe one of them is correct. Now this is not possible because if you look at your quadratic equation is kx square minus 2kx plus 6 equal to 0. Now k is your leading coefficient and the leading coefficient cannot be 0. So that's why this value will be rejected. The only possible answer is k equals to 6. Welcome back class 10th. We are doing exercise 4.4 from your textbook, page number 91. We have done the first two questions. Now we are left with the three statement sums of this exercise. If you look at the statement sums, you will see that all the statements begin by asking, is this situation possible? In each of the problems, you have been asked to verify whether such a situation would be possible or not. And to do that, we will be using the quadratic formula. So what we are going to do in these three questions, we will start the way we would normally do, assume the required values, form an equation. Looking at that quadratic equation formed, we are going to see if any answer for that equation exists or not. And whether or not the answer exists depends on the discriminant. The answer will only exist if the discriminant is greater than 0 or the discriminant is equal to 0. Means the roots exist. Either the roots are two different roots or the roots are two equal roots. But there is the third possibility when the discriminant is less than 0. In that case, roots do not exist. That means there is no answer. In that case, we will say that such a situation is not possible. The statement described in the question is an impossible situation. Let's look at question number 3. Is it possible to design a rectangular mango grove whose length is twice its breadth and the area is 800 meters square? If so, find its length and breadth. So let us do the question the way we will normally do. We have to find out the length and breadth, and there is a relation given between the two. The length is twice the breadth, so I'm going to assume the breadth as x. The units are meters. Since the length is twice the breadth, length will be 2x meters. And according to question, the area is 800 meters square. Now the area is given by length multiplied by breadth. So we are going to form an equation using this. 2x multiplied by x equals to 800. So 2x square minus 800 equals to 0. This is a quadratic equation because we have a term containing x square. But this is not in standard form. Let's express it in standard form. The term with x is missing. So the term with x can be written as 0x minus 800 equals to 0. If you want, you can write down quadratic equation. This is a quadratic equation. This is verified because we have a term containing x square. But this is not in standard form. So here I have converted it into standard form. So term containing x square, term containing x, and a constant term. Now I can compare with the standard form. Ax square plus bx plus c equals to 0. If this had been a simple problem sum, we would have solved this equation either by factorization or using quadratic formula. But in this particular question, you have to first of all check whether or not the answer exists, means whether you will be able to find the answer or not. You have to tell it before you actually solve it. And to do so, we are going to find out the discriminant. So let's take the discriminant from here. First, we find out A, B, C. A is 2, B is 0, C is minus 800. And now we find out the discriminant, and then we will decide whether we are going to find out the roots or not. Discriminant is given by b square minus 4ac. So this is 0 square minus 4 into a into b. So this will be 0 plus 6400. So this is 6400. 100 discriminant is greater than 0. So therefore equation has two distinct real roots. So this could also be written as yes, the situation described in question is possible. And now when we have told that this is possible, such a situation is possible where the length is double the breadth and area is 800, this is possible because the discriminant is greater than 0. The equation will have an answer. There will be two different answers from this equation. So now we can find out the answers for this. You could either go for factorization or you could use the discriminant to find out the roots. From here, the roots means the value of the variable. X can be calculated as minus b plus minus square root of d by 2a. Using the values, this will be minus 0 plus minus square root of 6400 over 2 multiplied by 2. So this will be 0 means 0. You can just ignore it. You will have a plus minus square root of 6400. This will be 80 over 4. So there will be two answers. This can be simplified. So we get plus minus 20. Now x is representing length. From here you have two answers, x is 20 or x is minus 20. Out of these, one value will be rejected because the length cannot be negative. So the value of x is 20. Based on this, we can find out the length and the breadth. So from here, the breadth is x. This will be 20 meters. And the length is 2x. So this will be 2 into 20 equals to 40 meters. Question number 4. Is the following situation possible? If so, determine their present ages. The sum of the ages of two friends is 20 years. 4 years ago, the product of their ages in years was 48. Now again, just like question number 3, we will begin by assuming the values, form an equation, and to answer whether this situation is possible or not, we are going to look at the discriminant of the equation formed. If the discriminant is positive or equal to 0, then the situation is possible. If the discriminant is less than 0, means we get a negative discriminant, then such a situation is not possible. Let's start writing down. Again, there are two things given. Use one to assume your values and use the other to make an equation. To assume the values, I'm using the first statement. The sum of the ages is 20. So sum of ages is 20. So let the age of one friend as x years. Therefore, the age of other friend. We have the total given. When the total is given, out of the total, one value is x. So the other one will be x minus 20. Sorry, it will be 20 minus x. Total minus x. They are talking about their ages 4 years ago, past ages. So let's find out their past ages. Age of friend number 1, you can just refer. This will be easier. X minus 4, going back 4 years. Age of the second friend. Presently he is 20 minus x years old. We are going back 4 years. So subtracting 4, this will be 16 minus x years. And according to question, the product of past years, the product of past ages is 48. So this means x minus 4 into 16 minus x is 48. Form your quadratic equation from here and then find the discriminant to see whether it will be possible to have such friends. So this on simplification, this is 16x minus 64 minus x square plus 4x, transposing this, simplifying, minus x square plus 20x minus 112 equals to 0. So I'm taking negative common, x square minus 20x plus 112 equals to 0. From here my quadratic equation is this, x square minus 20x plus 112. Now the next step is to find out the discriminant and then decide whether or not we are going to have an answer or not. Comparing it with the standard form. So A is 1, B is minus 20 and C is 112. Let's find out the discriminant. B square minus 4AC equals to minus 20 square minus 4 into 1 into 112. This will be 400 minus 448. This is minus 48. Now when we have a negative discriminant, the answer doesn't exist. So this is what we are going to write down. Discriminant is less than 0. So the situation is not possible. If you want, you can write down here, because when the discriminant is negative, less than 0, there are no real roots. We cannot find the answer for the equation. So if we cannot find the answer for this equation, that means such a situation is not possible. Now looking at question number 5. Is it possible to design a rectangular park of perimeter 80 meters and area 400 meters square? If so, find its length and breadth. We have solved the previous 2 questions, and in one of the cases the situation was possible. We were able to find out the answer. In the second problem sum, question number 4, the discriminant was negative. We were not able to find out the answer, so we said that the situation is not possible. We are going to do a similar thing here. We will work out with what's given, form an equation, calculate the discriminant, and depending on our discriminant we will answer whether such a situation is possible or not. In this question there is no direct relation given between the length and the breadth. We have only been given the perimeter and area, so that is what we will use to assume the values and make an equation. So I'm going to use perimeter to assume the values and area to form the equation. So just for myself, I am noting this down, that the perimeter is 80 and the area is 400. The units are meters. So I'm going to use perimeter to assume the values. Let length be represented by x. Now I'm going to use perimeter. Perimeter is 80. So this means 2 multiplied by L plus B is 80. From here, L plus B is 80 divided by 2. L plus B is 40. I have taken L as x. So B comes out to be 40 minus x. So I have assumed the length, I have assumed the breadth. Now I'm going to use these values to make an equation by using the area. Now I'm using this. Given area is 400. This means the product of length and breadth. Area of a rectangle is given by L into B. This is 400. So use the values. Length is x, breadth is 40 minus x. Form your equation from here. I'm taking these values to right hand side. So this is my quadratic equation. Now to see whether or not such a situation is possible, I'm going to look at the discriminant of this equation. And to do so, first of all, I will identify ABC. Comparing this equation with the standard form, ax square plus bx plus c equals to 0. My equation is x square minus 40x plus 400 equals to 0. A is 1, B is minus 40, C is 400. Let's find the discriminant. Discriminant is B square minus 4AC. Use the values. Minus 40 square. So this is 1600 minus 1600 equals to 0. So discriminant is 0. I'm going to have 2 equal roots. the answer exists. That means the situation described is possible. So I'm going to write down that the situation is possible and also find out the answer. So therefore, the situation described in question is possible. And now I'm going to give the answer. So roots means the value of the variable. Variable was x, will be given by minus b plus minus root d by 2a. Now discriminant is 0, so the roots will be minus b over 2a minus b over 2a. Let's use the values. B is minus 40 over 2 into a. This will also be same, the second root. So this will be 40 by 2, 40 by 2. So the answer is 20. There is only one possibility that x is 20. So therefore, whether we use this option or this option, answer would be same. So length will be 20 meters and breadth we obtained it as 40 minus x. So this will be 20 meters. So length and breadth are equal. That means this situation will be possible when we have a square, not a rectangle, because the sides are equal and the perimeter will be 4 multiplied by side. 4 into 20 will be 80. And the area of the square will be side square, 20 square, which is 400 as given in the question. This completes your exercise along with your chapter.